Hello, this is Keenan Maxfield, and I have a quick video here. This video is intended for a little bit more high level. I'm not going to talk about breakers, sizing the system. I'm not going to talk about circuit protection. This is assuming you already know all of these things. There are going to be some overcurrent protection devices that are missing from my diagram, and I'm assuming that you already know the requirements for how big you must size a battery backup system, because a battery backup system does not need, as far as the code is concerned, it does not need to be as large as a utility service. So with all of that in mind, let's get into it. Okay, so I ended up talking to two different people about a nearly identical circumstance 2 days in a row. So I figured I would just make a quick screen recording dealing with some options and obstacles for this situation. So here's the situation. We have a 400 amp meter. 400 amp meter main panel. And so this meter main panel, it comes off 400 amps into the center of a bus bar, and this bus bar is 320 amps continuous, but it's center fed, so that's how they deal with to get it to be on a 400 amp service. So then off of this meter we have two 200 amp circuits that then go to two separate sub panels that are in the house. So that's a 200 amp panel and another 200 amp panel. And this is common for like maybe an upstairs and a downstairs panel or other large home situations. And of course I've heard that 95% of homes are on a 200 amp service, but for that 5%, this is how it can be done. And so the question is, how can we back up both panels from one source? So there's a few ways to address this, but I am going to give one specific way to do this here in this video. So I'm going to get a little bit of a clean slate. I'm going to leave some of it there. Okay, so on one 200 amp panel, I'm going to treat this like a normal home, a normal backup, where we intercept this going into a battery-based inverter. So let's put it down here. And here's our battery bank. So this is the battery-based inverter. And this inverter will pass through the full 200 amps from the service into the pre-existing 200 amp service. So now that we've got that, it's like, okay, that takes care of one of them, but how are we going to do the other one? You could, of course, do a second inverter system, but now you've got two separate inverter systems, and that's not ideal. So here's one alternative option. We can put in an automatic transfer switch here. Automatic transfer switch has two inputs and one output. So this transfer switch automatically connects to the grid when power is available. So the grid is feeding this panel just like it was before. But then when power goes out, then this connects to this other terminal, which is fed by this inverter system. And now this inverter system can only produce whatever amperage it can produce during a power outage. And let's just say this is a 200 amp inverter system. Of course, now all your backed up loads are limited on that 200 amps, but for a battery backup system, that should be plenty. Of course, once the grid comes back, this automatically goes back to supplying it from the grid power, and this just feeds the grid power through here just like normal. This allows also for you to use a generator to back up both panels, to back up all the loads in the system. So in this case, that generator would tie in to the inverter, to the other AC input. Of course, you'd have to use an inverter system that has two AC inputs in order for it to be designed to accommodate this. But then your generator, which I often use this symbol for a generator, almost looks like a rabbit, you might say, or some other animal, and goes right into there. So then your generator can fill the batteries, back up your panels, and this gives you the ultimate backup reliability without having to completely replace this meter main. Because otherwise, how on earth are you going to supply both of those circuits? Also, if you have solar or windmills or anything in the system, they should most likely be tied either into this panel or off of a tap here that goes to a sub panel. So if this whole battery system is in a garage, hypothetically, and then these panels are deep in the middle of a basement, hypothetically, then you could have this split off to another little sub panel as breakers, and that could go to your solar and windmills. So many ways to do this, and obviously the more I draw on here, the more complicated it looks. But in concept, it really is quite simple. The AC coupled solar ties into here and will backfeed through here and backfeed the grid, or go in and charge the battery. It'll also flow out to feed the loads. And this inverter battery system can really control the battery charge and everything in order to maximize self-consumption, if that's a requirement for the site. Of course, in some cases, you can run CTs from this up so that you can monitor both lines in order to do better self-consumption. So lots of options, lots of ways to skin this cat, but that's the basics. Thank you very much.